You're listening to the Knowledge Archives podcast. Welcome to the Knowledge Archives podcast. We're a group of students on a mission to learn from as many different disciplines of knowledge as possible. I'm your host, Madhav Malhotra, and today I'm glad to be joined by Dafni Avgoustaki, a PhD student at the Aarhus University in Denmark. Her research focuses on optimizing vertical farms, especially in regards to their energy usage and lighting. So thank you for joining me today. I really appreciate you taking the time, and I'm very excited to learn about this up and coming area of work, and I think it's really, really important what you're doing. But I guess before we start talking about all of these different aspects of vertical farming, it would be great to just hear a little bit about yourself, your background, and how you got started in this area of work.
Yeah, of course. Well, thank you very much for inviting me, Madhav. I am really excited for this. I am Dafni Avgoustaki. I am originally coming from Greece, but I live in Denmark for the last 3 years to do my PhD studies. As a background, I'm an agriculture engineer, and I have 2 masters in robotics and automations in greenhouses and undercoverage agriculture. And then for me, the inspiration for my PhD was, okay, what it is after greenhouses, what is the innovation now in agriculture, and how we can make it even more sustainable with maximized yields and bring the farms closer to the consumers. So the last 4 or 5 years from when I started my PhD, it was introduced the term of vertical farming in the global community. And that gave me the sparkle to try to translate my background into a more sophisticated PhD that involves the vertical farming project. So I moved here. That's why we started. I started my project and I started digging into more and more into vertical farming, but from the energy sustainability perspective. After the first year of my PhD that I had already conducted some primer research, I start getting really enthusiastic with the concept of entrepreneurship and how we can actually bring smart solutions into vertical farms. And since I'm also in Denmark and there is a lot of renewable energy and the energy exchange system of Nord Pool, there was an opportunity for me here to develop also my business part of my personality. So we start developing VerdeCube. It's a smart solution, a smart decision tool for vertical farms and in general for artificially lighted farms.
Yeah, it's great to hear about all of that background, and I'm very excited to dive into those specific details afterwards. I guess the first big question, though, to start off is why is it that we're now starting to go from a conventional agriculture-based model, or even with modern systems like greenhouses, to now incorporating vertical farming?
Yes. So the global population is constantly increasing, and the food that we're actually producing by open field agriculture and only by greenhouses is not enough to cover all this increasing demand. At the same time, most of the population is gathered in urban areas, and in order to cover all this population, now we need the size of Latin America to cover the food demand of the global population. But the researchers project that until 2050, with a huge increase of global population from 7.2 billion that it is now to around 9 to 10 billion, we will need an extra size of Brazil if we only continue practicing the agriculture techniques that we practice now. Also, we tend to destroy the forest and the land areas that they are still virgin in order to create landfills for food production. So due to all this increasing demand, and at the same time, there is a huge technological increase and innovations in a global scale, the researchers like the Spomnier and Toyoki Kozai are some of the fundamentals mentors of vertical farming from USA and from Japan. They start creating the concept of vertical farming with technologies that we already using in greenhouses, like hydroponic systems that consist soilless cultivation techniques that we input the plants in different substrate materials, and they are able to grow their roots in a much more sustainable and efficient way with higher water use efficiency and nutrient use efficiency. So we had these technologies already from smart greenhouses, as we have, let's say, in Netherlands, in Europe, or in USA and in Canada. And they try to put this in a 3D dimension because the 2D dimension was not enough for food production. So the concept was, as we put people in urban areas in stacked buildings, one above the other, this is the same way that we should also grow our food in the urban areas. The concept is really based on how we can achieve the maximum of yield that we can produce per unit of land area, but with a smaller resource use inputs and high efficiency that we can achieve.
Yeah, it's great to hear about that background with this technology. Can we keep diving more into the specifics? Like, how do things operate inside one of these units?
So we have really well thermal insulated growing areas that they are protected from outdoor weather conditions and allow farmers to avoid the vulnerability and variability of the crops due to severe weather conditions, insects, bacteria, and many other factors that can cause damages in the yield quality and quantity. So we brought the crops inside, but we want them to be well thermal insulated and totally isolated, as I mentioned before. So we couldn't use the solar radiation because that would leave our system semi-open from damages, and it wasn't fully operated and fully automated. So we start using artificial light that has highly evolved during the years. That at the beginning was high pressure sodium lamps and fluorescent lamps. Now we mainly use LED lamps because of the high efficiency and efficacy of electricity light that we use. And researchers try to optimize the 3 dimensions of light: the light quality, meaning what is the nanometers band of the spectrum that lamps have in their specifications and provide to the plants. And I have also listened to the comment that why the lamps are giving purple light, is this nuclear energy? No, it's not. It's because the lamps provide only the specific nanometers that the plants are actually able to absorb and use for their photosynthesis processes. So for the plants, research has shown that the most ideal bands of the spectrum is the blue, the red, and the near infrared parts of the spectrum. Blue and red gives us purple. This is why most of the interior farms, you see them in purple. Then it was the light quantity, meaning the intensity, how many photons are leaving from the lamps to the plants, and the light duration, the photoperiod, as we say it, how many hours of light do the plants receive on a daily basis. So they start seeing that plants actually can grow really fast. They can control a lot of parameters in plant growing, like also apart from the size of the plants, we can also play with the color, texture, taste, and the different lighting solutions. So there is a very high increasing interest in the lighting specifications of each farm.
Wow, yeah, it really seems like lighting is a really important factor in these vertical farms, and I'd never imagined that just the change in lighting could make such a huge difference.
Yes, but also due to the multiple hours of operation of the lamps, because they usually operate them between 12 to 24 hours daily, which is highly dependent on the plant species, the growing stage, many different factors on how long we actually operate their lamps daily. But this consists one of the biggest costs of vertical farms, and we have really high demand on electricity to maintain an optimal environmental solution for our crops, but also to provide a more automatic environmental solution. So in general, vertical farms are usually located into the urban or peri-urban areas. So in that way, we are able to avoid the food miles and the CO2 emissions that come from food miles, since food is around 2,000 miles away from the producers to the consumers, and they have to travel it every day. We have losses of crops, we have lower quality, limited shelf time. So when we brought the crops into close to the consumers, we were able actually to provide them a much healthier, fresh and nutritious food for them. Since they are so automated, they allow farmers to implement really high technologies and also work with renewable energy in smart grid systems, like with wind turbines, with solar panels, or with geothermal energy to absorb the energy and use it for the requirements of the operation of the farm. So it's really based on the high technology that we can apply and the concept that we produce food for the local consumers.
Yeah, it really sounds like a futurist dream in all of these different aspects of technology just coming together to improve the efficiency. And, as someone from the public, I see all of these futuristic lights, I see all of these amazing renewable energy sources, and I'm like, why is this not everywhere? So you were talking about the cost, and that's one thing. So you talked about the energy costs as a part of that. Would you be able to dive a bit into if you have an estimate of the fixed cost of, say, implementing a vertical farm versus a conventional farm? And then are there any other variable costs that we need to consider besides lighting?
Yes. So in general, at the beginning of a breakthrough technology, there are always challenges that you have to face. And the more the years are passing, the technology becomes cheaper and cheaper due to the increased and advanced optimization that is coming. The same case was for vertical farming. Of course, with the passing of the years and a lot of research, still there is a lot of space for optimization, mainly in the lighting, but also in general in the cultivation techniques that we apply. But the cost of LEDs is constantly increasing, but at the same time, the efficacy, the efficiency of the lamps, how many photons they are actually able to produce, is constantly increasing. People have to understand that vertical farming is not in a target to replace open field agriculture. It's not the target of actually being able to grow everything and anything that we want into the vertical farms. And this is because being in the urban areas is expensive. It's more expensive to pay your rent if you're close to a city. You have advanced labor demand, which is one of the biggest costs, because you, apart from not needing a lot of people to actually perform manual operations like harvesting, transplanting, and other processes in the farms, you need people that they are really specialized and have a sophisticated background on how to actually monitor and management this kind of production level. So we have high labor costs, and then one of the biggest is the energy costs that we have in terms of operational, but also in capital expenses. So lamps require big initial investment in order to place them into the farms, because there are specific dimensions, the densities of the lamps that we need to calculate and put a lot of numbers of lamp and wiring, electricity. So lamps have high initial investment, but then also have high operational expenses for the farm. I think they consist almost 40% of the production cost of the farm, which is almost 7 to 9 euro per square meter per month only for your light operation of the farm. Then apart from that, in terms of electricity distribution, are the pumps that we have for the nutrient delivery and air conditioning for cooling. So, but still these are lower ratios in the total electricity demand of the farm. So in terms of the operational expenses, what we see is energy lighting, labor, and packaging, delivery. So these are some minor expenses. However, the important is to compare the resource use efficiency that we can achieve between vertical farms and traditional farming. Traditional farming is a type of farming that it is really difficult to control because it's so vulnerable to the outdoor conditions. So we use a lot of water for irrigation that can be reduced 85 to 97% with the use of closed loops in the vertical farm. So the water is irrigated and then is recirculated, they filter it, and they are able to reuse it again and again and again into the crops. So we can achieve high sustainability on that, but also we can reduce around 40% the CO2 emissions that are coming from the transportation of the food. Of course, we have significant increase in the energy use efficiency that still needs further optimization. Then we don't apply any chemical inputs like pesticides, herbicides, and of course we don't have agricultural runoffs that we observe in traditional agriculture. So yes, there are a lot of studies that show differences between the operational and capital expenses among these two type of farms. And I can give you, like, for vertical farms, if we want to produce 1 kilo of fresh lettuce with the open field techniques, we need around 93 square meters of growing area. If we translate this to a greenhouse, we need around 40 square meters. But then if we translate this to a vertical farm, for the same amount of lettuce, we need 0.3 square meters of growing area, meaning that we can actually shrink a lot the land that we actually use for food production and maximize it further and further. And this is the goal of vertical farming, to maximize your yield with the least possible resource input.
Yeah, it's great to hear about those specific numbers. Thank you for bringing those up. One thing that I am curious about now is that after hearing about these costs and the importance of optimizing them, I thought it would be great to hear a little bit more about your own work about this when it comes to lighting in particular with VerdeCube. And also, if you do know of any other innovative companies that are also working on this problem, those would be great to hear about as well.
Great. So, as I mentioned before, light has a significant importance in horticulture, and there are a lot of studies that focus on the light quality selection, meaning which parts of the spectrum are combining for better crop production, and also the intensity, like how close are the lamps, what is the distance, the optimal distance between the lamps and the crops in order to receive sufficient amount of photons. In my case, I focus on photoperiod, the period of light that actually plants are able to receive during a day. And we try to optimize and play with the photoperiod. And what we developed in my PhD studies is we were focused a lot on the Danish electricity market, as I mentioned before, Nord Pool, which is a system that exchanges energy prices between the Nordic countries of Europe and the Baltics. And we are able to forecast the electricity prices for a day ahead, the exchange numbers between the countries. So the electricity price is a fluctuating system like you also have in Canada. And it's not a stable price. So this allows us actually to see what are going to be the lower electricity prices and the higher electricity prices during a day, and shift the energy demand response on the cheapest electricity prices. But because the prices are not only reducing or only increasing, and they are actually fluctuating a lot, what we performed in our experimental sessions is an intermittent lighting system, where the lamps switch on and off based on the electricity market prices, but without affecting the growth rate and the development rate of plants. So in order to achieve that, we constantly monitor the environmental conditions, both of the growth area, but also of the plants in terms of their substrate temperature, the chlorophyll content, the photosynthetic rate. So we monitor how much actually the plant's growing when we apply intermittent lighting, and we can actually save electricity by fitting this energy system into the most sustainable and cheap hours. So that was the concept of our optimization. And this is also the basis behind VerdiCube, which is, as I mentioned before, my startup that has a software algorithm that uses the dynamic light provision that is linked with the electricity market price fluctuations. And we combine it with data analysis from monitoring and plant physiology, morphology, development, and growth rate. So we are able to provide at the end to the farmers an intermittent lighting system that the lamps switch on and off based on the electricity market prices. Of course, there are many solutions around the world that provide optimization and smart solutions inside the vertical farms. The point is, when the market and the investors are going to be in that point that they will totally support vertical farming in order to bloom, because in vertical farming, we can actually grow a lot of high purchase value crops, like the ones that means a lot in terms of economical value. So we grow fresh salads, herbs, flowers, medical cannabis. Medical cannabis may not be in such a vertical sequence, but it is in an indoor installations that they use the automated systems and the artificial light, but maybe without the vertical layers one above the other. But yeah, there is a lot of room for many optimization and growth in this field.
Yeah, it is just so incredible to hear about all of these new technologies and all of this new growth. I think what fascinates me the most is actually how for thousands of years we've just been farming this one way, and now just within the last few decades we've had so much incredible growth, and yet, as you've said, this industry still is so ripe for disruption. There are so many new initiatives to optimize things, so I'm very excited to keep on being updated with what comes next in the field. And I really wanted to thank you for taking the time to explain all of this insight. It was really fascinating to me, and I'm sure lots of other people learned from this episode as well.
I hope I was a little helpful to give you some insights on this project, on this concept of new farming, and possibly what we really expect as scientific community is the acceptance of society to this novel type of farming, and people embrace it and actually support this kind of products with less skepticism, and feel that it's one of the safest way for food production when everything is controlled.
Yeah, I think this is going to be helpful for more people to be educated about that, and I'll be sure to include a few of the links to the companies you mentioned or the research papers that you've been putting out, and I really appreciated you sharing your knowledge today.
Thank you very much. Thank you very much. I wish you the best and keep green.